Okay, in this video I'm going to work out the solution to most of the problems in the study guide. Make sure to have the study guide handy because I'm not going to write the questions. I'm going to begin with the first question. Number 1. Which of the following is not true of statistics? Well, it turns out to be B. B says statistics is used to answer questions with 100% certainty. That's not true about statistics. In statistics, we can never be 100% sure, so we choose B. And number 2. Determine whether the underlying value is a parameter or a statistic. The 90% here. A study of 3,000 college students in the city of Bambleton found that 90% had been victims of violent crimes. Well, the 90% comes from a sample of 3,000 students, and anything that comes from a sample is not a parameter, is a statistic. So if it said all college students, then in this case you would choose a parameter, but we're going to choose B, statistic. Number 3. Classify the variable as a qualitative or a quantitative. Number of calls received at a company's help desk. Well, number of calls is has a numerical value. It could be 0, 1, 2, 3, etc. So this is a quantitative, so you choose A in this case. Number 4. What is a qualitative? Qualitative is not a number, it's an attribute. Okay, let's go to number 4. Let me read number 4 now. The number of seats in a school auditorium. Well, this is also quantitative. So we choose A, because A says a quantitative. Number 5. Determine whether the quantitative variable is discrete or continuous. Discrete means we can count them. Continuous are not countable. The weight of a player on the wrestling team. Anything that has to do with measurement, guys, is not discrete. Even if you stand on the scale and see that your weight, let's say it's 150 pounds, but is it exactly 150 pounds? No. So in this case, anything that is measured is continuous. So you're going to choose A for this. Or number 6. The number of goals scored in a hockey game. Well, that's countable. It could be a 0 or a 1 or a 2 or a 3 or a 4 and so on and so forth. So that's discrete. We choose B. Number 7. Determine the level of measurement of the variable. There are 4 levels of measurement. Nominal is qualitative data and cannot be ranked. Ordinal is qualitative or quantitative but can be ranked. Interval, it's a quantitative data, but the 0 means something like temperature. And ratio is everything else, but the 0 means nothing, is the inherent reason. The medal received, gold, silver, bronze by an Olympic gymnast. Well, this is not a quantity, so that's a qualitative, but it can be ranked. Gold comes first, and then silver, and then bronze, so that's going to be ordinal. Number 8. Okay, let me scroll down to 8 and see what's 8. Weight of rice brought by a customer. That's a ratio. That's a quantity. You can compare, you can add, you can subtract. So that is a ratio, and we're going to choose C. 9. A student's favorite sport. Well, that's a qualitative, it's not a quantity, so that's going to fall under nominal. So that is C. Number 10. Okay, let's do it right here. The government of a town needs to determine if the city's resident will support the construction of a new town hall. The government decides to conduct a survey of a sample of the city's resident. Which one of the following procedure would be most appropriate sample? Survey a random sample of employees. Why just the employees? That's not fair. Survey every 12th person who walks into a city hall. Why just people who go to the city hall? So that's not an appropriate response. Survey a random sample of persons within each geographic region of the city. That sounds very reasonable. Let's look at D. Survey the first 400 people listed in the town's telephone directory. That's not fair. So it's going to be maybe people who belong to one or two families, because they are on the first few pages of the list. So C would be the most appropriate answer. Number 11. Identify the type of sampling used. Every fifth adult entering an airport is scheduled for extra security screening. What sampling technique is used? When you use an interval like that, every fifth or every sixth, once you see this word, guys, you're talking about a system. You are creating a system. So this is systematic. We use E here. Number 12. Identify the type of sampling used. A travel industry researcher interviews all of the passengers on 5 randomly selected cruises. What sampling technique is used? Well, there are hundreds of cruises. So you're taking 5 cruises and you're interviewed everyone on board of each cruise. This is what we call cluster. Cluster means you divide the population into segments and you take all the members in one or more segments and put it in the sample. So that's what we mean by cluster. So 12 is going to be B. 13. Okay, let's see what 13 says. Same question. Lobbyist for the oil industry assigns a number to each senator and then uses a computer to randomly generate 10 numbers. The lobbyist contacts the senators corresponding to these numbers. What sampling technique was used? In this case, this is the best way to sample. This is called the simple random sample. It's not cluster, it's not stratified. You didn't say that he's going to divide the population into segments. So the most appropriate answer will be a simple random, which is D. Number 14. A writer for an art magazine randomly selects and interviews 50 male and 50 female artists. What sampling technique is used? Well, there is more than 50 male artists and 50 female artists, so he divided the population into 2 segments, male artists and female artists. He took 50 from the first one and 50 from the second. This is an example of stratified. So that's going to be D. Okay, 15. Let's see what 15 is about. Before opening a new dealership, an auto manufacturer wants to gather information about car ownership and driving habits of the local residents. The marketing manager of the company randomly selects 1,000 households from all households in the area and mails a questionnaire to them. Of the 1,000 surveyed male, she receives 140 back. Determine the type of bias. Well, the problem, with mailing, not all people respond to mail, and most people even don't look at that mail and consider it junk mail. So the bias is that there was a great chance that most people were not going to respond to the survey, and that explains why only 140 responded. So it's the non-response here. As I said, not people would want to make an effort and write back and go to the post office and deliver their message or deliver their mail. So that explains why very few answered the survey and responded, to the request. Number 16. The class width is the difference between 2 successive lower class limits. Yeah, that is correct. Or 2 successive upper class limits. So you choose A here. So for example, let me give you an example here. Let's say we have 2 to 5 and then 6 to 9. What he means by 2 successive lower class limit is 2 and 6. What's the difference between 2 and 6 is 4. And you can do upper limits. The difference between 5 and 9 is 4. You can find the class widths this way. 17. A researcher records a number of employees for each of the IT companies in the town of Westmore. The results are summarized in the table. Find the class width. If we've done 16, we should be able to do 17 easily. I'll take any 2 consecutive classes and do the difference between the 2 lower class limits. So you can do 250 minus 0, or you can do 500 minus 250, or 750 minus 500 to get the class width. So it will be, let's say, 250 minus 0, which is 250. And if you check 250, that's going to be A. Okay, so we're going to go to 18 now. Okay, so we need to create a frequency distribution table in number 18. He wants 5 classes. So I'll go and look for the lowest value and the largest value. So 18. Lowest value is 67. Largest is 74, and we want 5 classes. So the class width, guys, as you saw the formula, will be 74 minus 67 divided by 5, which is going to be 7 divided by 5, which is going to be about 1.4. But as you learned, you always have to round up. So you should round up to 2. 1.4 will go up to 2. But the problem is, in this particular problem, but it will not happen on the test, if you round up to 2 and try to create the classes, the last class is going to be empty. It's not going to have anything in it. So if you check the answer in the back for number 18, instead of using 2 as the class width, he used 1.5. So I'm just going to show you how the 1.5 was worked out so you understand. But on the test, 1.4 goes to 2, but I'll make sure that the data set would work this way and you will not get any classes without any frequencies in there. So what happened here, we just we take the time in minute, compute time in minute, then you do the frequency, and then you do the relative frequency. Okay, so the smallest number we said it's 74. The class widths we said we're going to use 1.5. On the test I would like you to use 2. It will work, but for this particular problem it wasn't going to work. So 74 and add 1.5 here will be 75.5. So this one is going to be 75.4 since we're using decimal here. And then you start adding 1.5. Oh, it wasn't 70. I'm sorry. The smallest number was 67, what I'm talking about here. So if we add 1.5, it will go to 68.5. Let me just erase this. Alright, and I'll rewrite it. Okay. So we have 67. And if we add 1.5, it will be 68.5. And if we add 1.5, it will be 70. We add 1.5, it will be 71.5. And if we add 1.5, it will be 73. Now here, go 0.1 behind 68.5, it will go 68.4, and then start adding 1.5, there will be 69. Point what? Here 0.9, and then 71.4, and then add 1.5 will be 72.9, and then add 1.5 will go 74.4. And then to figure out the frequency, guys, go to your data and see how many values are between 67 and 68.4, inclusive of 67 and 68.4. You're going to find that there is a 6. For this one, you're going to find out that there is a 5, then 13, then 2, then a 4. Now, how do you find the relative frequency? The relative frequency, you just take the 6 and divide it by 30, which is the total. And this is going to be 0.2. But since he said he wants 3 decimal places, we'll just give him 3 decimal places. And then you do the same for the remaining number. For example, for 5 over 30 will be 0.167, and the next one will be 13 over 30, 2 over 30, and the last one is 4 over 30. This is how we do number 18. Okay, for number 19, he wants a frequency histogram. So let me show you how to do that. A vertical line. Make sure to use a straight edge in here. The first class is 135 to 139. You can take the midpoint of this one, which is 137. And we're gonna label, we have up to 15, so I can go, guys, like a 5, a 10, and 15. And the class width is 5. If you take the midpoint of the first class is 137 and it is 6, so you just go a little bit higher than 5 and put the midpoint right here, 137. Then the next one is 4, so it's going to be a little bit lower than 5. And 137 plus 5 is 142. And let me do one more and then you can do the rest. The next one is 11. 11, I have to go a little bit above 10. Okay. And 142 plus 5 will be 147. Okay, let me do the rest. And 15, so that's gonna go to the top right here. Uh, 147 plus 5 is 152. And the last one is 8. 8 is a little bit less than 10. Definitely, guys, you want to use a straight edge, but I'm writing on the screen, so I can't just do that here. 152, and then if I add 5, it would be 157. Label the x-axis, which is called weight in pounds. I would just put that in here. And for this one is frequency. If he asks you to do a relative frequency histogram, instead of 5, 10, 15, you would use the decimal one. So I'll do 5 over the total, 10 over the total, and 15 over the total, and that should give you the histogram that he wants. In number 20, he's asking about the difference between a bar chart and a histogram. Well, you know, in a bar chart, the bars do not touch and they're separated, but in a histogram, they're attached to each other. There are no gaps in a histogram. So in this case, we're going to choose B because it says the bar on the bar chart do not touch, while the bars of a histogram do touch. So B makes sense in here. 21. The heights and inches of 30 mechanics are listed below. Construct a stem and leaf plot for the data. Since this is a 2-digit for the stem and leaf plot, you're just going to do this. And what do I have? 70s and 60s. So we're just going to have 2 stems, guys, in the 6 and the 7. So that's only 2 rows. So not a lot of work here. So I just put a 6 and put a 7. And you start putting the leaves on the other side. There is a 67, there is another 67, there is, I think there are 4 68s and 5 69s, so you just record them like that. For the 70s, I got 1, 2, 3, 4, 5 70s. And I got how many 71s? 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. And I got 72 twice, 73 twice, and 74 twice. So this is your stem and leaf. Now you have to put a key here for a reader to understand what you're doing. So you just put 6 and vertical line and tell the reader that that means 67. Okay, let's go to the next question, 22. Okay, for 22, he's given us a distribution, asking us what's the shape of the distribution. So it looks like this. It looks like it's a little bit skewed to the left, so your answer will be that this distribution is skewed to the left. I would choose A here. Okay, let's go to 23. In 23, he wants us to construct a frequency polygon for the data. It's the same thing as doing a histogram, what you do. So let me just show you here. The first class starts at 50 to 52. Okay, so we're here. What's the midpoint between 50 and 52? It's 51, and the class width is 3. So I'm just going to go 51, 54. The next one, how many do I have here? And then, oh, I have 5 classes. So 57, and then 60, and then 63. 51, what is the frequency between 50 and 52 is 5, so you need to label this one as well. The highest number we want is 12. So I'm just going to do 4, 8, and then 12. You can check the answer in the back. It's done using the computer, but just I'm going to show you a rough sketch of this one. So 50 to 52 is 5. This is going to be right here. 53 to 55, the midpoint is 54. We have an 8, so it's going to be somewhere here. And the next one, 56, is 12. It's going to go all the way here. And then Oh, we went to 13, so there is one more. The next one is like at 13. And then 11, down to 11, right here, almost. Okay, the first class begins, let's say, right here at 50, and the last one ends at 64, almost right here. So what we do is just connect it like that. And then all the way down. This is called a polygon graph. 24. Let's see what 24 is about. Explain what's misleading about the graph. So I see a 2 by 2 and then I see a 4 by 4. The volume, and they make a claim that the volume of our sales has doubled. So what's misleading here? You notice that the length was 2 and then the length became 4. So the length has doubled. But what about the area? What happened to the area here? The area did not double. It has been multiplied by 4. Count the small square in the first one. You have 4 square, but in the next one you have 16. 4 times 4 will give you 16, but the length has doubled. So this is not a good representation of what happened. I will choose D in this case. Okay, 25. Okay, let's see what 25 is about. Find the mean, median, and mode of the following statistics. You guys, you can do this using your calculator, or you can do it by hand. If you do it by hand, make sure to rearrange the data in order in order to get the median. But if you want to use your calculator, you just go to Stat, Edit, and press Enter and go and enter the data into L1. After you do that, you go to Stat, Calculate, and then one variable Statistics. I made a video to show you how to use a calculator to find the measures of center and measure of dispersion, so make sure to check that. Make sure that L1 is selected, and then if you have a newer calculator, scroll down and press Calculate. It's going to give you, the first value it's going to give you is the mean, which is X bar. In our case, the mean is going to be 61, if you do the math. The median, it's a Q2, but you can write median here. It turns out to be 62. The calculator does not give you the mode. The mode is a number that occurs most frequently, and I noticed 63 occurs 3 times, so it must be 63. Okay, so that is question 25. Okay, the next one is 26. Let's see what 26 is about. What's misleading about this graph? You know, right away I look at the vertical line and see if it starts at 0. If it does not start at 0, this is a misleading graph, and it doesn't. As you notice, it starts at 10,000, so you can choose B for this one. 27. Find the sample standard deviation. You can use your TI, and I do want you to use your calculator. Do not do it by hand, guys. Again, in order to use a calculator, you go to Stat, Edit, L1, and put your data in L1. After you do that, go to Stat, Calc, scroll over to Calc, one variable is Statistics, and then if you have an older calculator, press Enter, Enter, it will work. If not, you're going to get a new screen. It's going to ask you, is L1 the list that you want? So Enter, and then scroll down to Calculate. And once you scroll down to Calculate, you will get your answer. The standard deviation, since he says it's a sample standard deviation, you choose SX. And it turns out to be the value for 27. If you do the math, it's going to be 3.7. So that is 3.7. 28. The April precipitation amounts in inches for 10 cities are listed below. Find the range. That's a very easy question. The range is the difference between the smallest and largest. So range, guys, equals maximum minus what? Minimum. You can easily do that. The calculator does not do that for you, so you can just do it. It takes less than 1 minute to get this one done. It's going to be 3.2. So do the math and you should get 3.2. In a random sample, 10 employees at a local plant were asked to compute the distance they traveled to work to the nearest tenth of a mile. The data is listed below. So this is a sample. Compute the range, sample standard deviation, and sample variance of the data. Use your TI calculator. You just, guys, do exactly the same thing as in 27. And the range is the difference between the largest and the smallest, so you can get it from here without using the calculator. And the standard deviation will be for number 29. Let me show you what the standard deviation is going to be. 1.8, and it's S. Now, what is the variance? Variance is S squared, so you just take 1.8 and square it, and you'll get the answer, which is about 3.32. Okay, so that's 29. 30. Over the last 10 years, 4 mutual funds that all had the same mean rate of return, 12%. The mutual fund had different standard deviation as follows. Mutual money is 80% standard deviation, co-joint investment 6%, together fund 4%, all for one fund 9%. Which mutual fund investment is the most consistent? Remember, guys, consistent means a smaller standard deviation. So which one has a smaller standard deviation is the together fund. So number 30, the answer is together fund, because it has the smallest standard deviation. I'm going to stop here, guys, and produce a second video because this is a 33-minute long video, and the next one I will cover the remaining questions.